Okay, welcome to 4.2. We're going to be doing pretty much the same thing this time, but it's just going to be tougher questions now. So let's kind of jump right into it. So you guys can look at these ones if you want. It kind of goes through how they do it. Just for the sake of time, I'm going to jump into the next one here. So the build your skills. Okay. So number one says calculate x in the following diagram. So the way these are going to work is it's going to be kind of like it's a bit of a puzzle, right? So we have all the tools that we need, but we're just going to see how we can get to the end there. So for this one, the key bit here is that, well, what I'm always thinking is if I'm going to solve for x here, I need two other things. You need like maybe, they got an angle, so that's one thing. But I would need like, this side or something else if I was going to figure out what x was there. So step number one is we got to figure out just one of those other sides. So then you kind of look over to the side here. And I was thinking, well, potentially maybe we could figure out what this side was because we've got 4.9. But again, that's it. That's all you have is 4.9 in this triangle over here. So that didn't really do it for us. But what if you look and notice that this entire thing is a right angle triangle, right? The whole thing there. Well, then, of that giant triangle, I know that the opposite side is going to be 4.9, and the angle is still 37 of that giant triangle. So if I use those two bits of things, I'll be able to figure out this side here first, and then use that to figure out that after. Okay, so I want to figure out this one. So what we're going to do, go to your formula sheet, and you're going to say, okay, well, on mine, I've got the angle, and I've got the opposite, and I'm looking for the adjacent. So which of these things over here has opposite and adjacent? So not sine, not cos, it looks like tan. So that's the one I need. Tan theta is equal to opposite over adjacent. So I write that down. Tan theta is equal to opposite over adjacent. Okay, now fill in what you know. So we know the angle, so I'm going to write tan 37 degrees is equal to, and now I know the opposite was 49, or sorry, 4.9. So 4.9 over, and let's call this, instead of x, let's call it, I don't know, anything else. We call it y. So over y. Okay, now we just need to solve for y. And remember that little trick I told you? If you just put this over 1, now we can do our cross-multiplying thing, or our fish method. Yeah, or you could solve algebraically, so either one to get you the right answer. So we're just going to go 4.9 times 1 divided by tan 37. So 4.9, and then times 1 doesn't really do anything, right? But if you want to do it, sure, times 1, still 4.9. Divided by, and now remember in your calculator, it's going to be 37 tan. And you can see it up top here, 4.9 divided by tan 37, but I still need to go equals. So that's going to be 6.5. So y on this side now, I just figured this out, is going to be equal to 6.5. Now, I'm going to do this again. So I'm going to use that. Okay, I'm going to use that to solve for x now. So in this case now, I've got a right angle triangle like right here, right? And if I'm looking at this new triangle, this one here, then the x is going to be my adjacent side of this triangle, and 6.5 is going to be the hypotenuse. So look at your formula sheet. I need adjacent and hypotenuse. Well, that's cosine. That's the one I need. So it's going to be cosine theta is equal to adjacent over hypotenuse. Okay, and again now just fill in what you know. So it's going to be cosine of, and it's 37 degrees again, is equal to, and now this time we're looking for the adjacent. So, and it was called x, so I'm going to keep it like an x, over 6.5. Okay, and then if you wanted to, you put that over 1, and if I want to solve for x, it's just going to be 6.5 times cos 37 divided by 1 would give me x. So we'll go 6.5 times 37 cos equals 5 point, and probably round that to 2, 5.2. Okay, so in the end we got x is equal to 5.2, and then circle your answer. Alright, number 2. So now we are going to have to start to use some other methods here too now. So not only just using our SOHCAHTOA stuff, or our trig identity, that's this stuff is what I'm talking about over there. Now we might also need to use Pythagorean Theorem. So you can see here, if I'm solving for x, well, that's as easy as a squared plus b squared is equal to c squared. And you can figure out what x is there, right? Remember though, just to take this, if when you figure out what c squared is, like when you go 9.4 squared plus 8.6 squared, you have to go to the square root of that to figure out what x is there, right? Okay, and then once you figured out x, now you're going to know this side, and you're going to know the angle. So you have two things, you can find a third, and then you just need to pick the right trig identity. So then, then you just need to pick which one of these things you're going to deal with. So probably give me a hand with that one. You're going to have your adjacent side, and you're going to have you're looking for your hypotenuse. So adjacent and hypotenuse, it's going to be a cosine one. Okay, so I'm going to let you guys do that one on your own. So go ahead and give me an answer for x and y for number 2 now. Okay, moving on. Okay, so for B, we're going to have a few that are like this one too, right? It wants like the x value for the total thing, the whole side length here. Well, that's actually pretty straightforward. We've just got 2 questions here. So this 6.7, well, that's going to be this length for both triangles, right? So now we just get to use that 6.7 for this triangle to figure out this side, and then this one to figure out that one, and then you're just going to add the 2 together, and that's it. So just got to make sure you figure out the right equation to use. Maybe I can give you a little bit of help with that one. So let's say for this one here, we're going to have the adjacent side, right? 6.7 is the adjacent side of that, and we're looking for the opposite. So adjacent and opposite, that's going to be tan. So this one's going to be a tan question. Okay, and then it's actually going to be the same for this triangle down here too. So okay, and then just remember to add the 2 together, and then that's your answer. So go ahead and answer 2B now. Alright, number 3. Okay, so if you want to do 3, that's great. It's a tougher question, I think. If you don't though, that's fine too. So we can cross off number 3. Okay, let's move on. So if you want to look through one of these examples to see how they do this one, great. I'm going to move on though. Okay. This is kind of a typical kind of a question. So it says from the top of a 200-meter tall office building, so they've already even drawn it in for us. The angle of elevation to the top of another building is 40 degrees. That's that. The angle of depression to the bottom of the second building is 25. So that's that one. How tall is the second building? So now it's just a matter of like piecing everything together now. So if this is 200, like, from there to there on that building, well, that's going to be the same here, right? So that's also going to be 200. It might be a little bit more helpful to kind of look at it over here, because now we have a triangle going on. So if I've got that, that's good. If I want to figure out the height of the second building, all I really need is this, like what's left, and then I'm good, right? So that's kind of what we're after. But if I'm going to find that, I need a bit more information for this bigger triangle. I need one more thing. Right now I've only got 40 degrees. I also need the length of something there. So what I'm going to do is figure out what the length of this is, right? Because if I can figure that one out, and then once I know that, I can figure out this. Okay. So if I want to figure out this first, well, that's my adjacent side of this triangle, right? So let's go, so it's going to be tan. So we'll say tan 25 degrees is equal to, and then opposite is 200. over, and then we're looking for that x. So that's over 1. So then that's going to be 200 times 1, which is just 200 still, divided by 25 tan, and then don't forget to push equals 428.9. That's what x is equal to, right? Remember that was that part. So we got that figured out. So I can even write that in here if I want now. So this is 428.9. So now I'm just going to use that to figure out this. And that's going to be the tan again for this bigger triangle. So step number 2 is going to be to go tan 40 degrees is equal to, opposite is the one we're looking for there, right? I'll call that maybe y to use a different variable. So y is my opposite over 428.9 meters. That's over 1. And then we'll go, well, it's still on my calculator, so I'm just going to go with that. And then times 40 tan. And then don't forget to push equals 359.9. Okay, and we're almost done. So now we have that height. Last thing we gotta do is just add 200. Okay, so in the end, our answer is gonna be, we'll say B2, because that's what we're looking for, is gonna be 359.9 meters plus 200 meters, which is equal to 559.9, 560 probably is what you rounded to meters. And that's your answer. Okay. Number 5. An extension ladder must be used at an angle of 65 degrees at its shortest length. It is 18 feet long. Fully extended, it has a length of 32 feet. Okay, so the hardest part of this one's actually just going to be kind of drawing it out, I think. So if we draw... Okay, so it's going to be something like this, right? So we've got the red one's going to be my shorter ladder. So that would be 18 feet long. And then the blue one is going to be my longer ladder, which is 32 feet long. Okay. I didn't really draw these to scale very well at all, but you get the idea anyway. Okay, so now we know that the angle of elevation here is going to be 65 degrees for both of these. Right? 65 degrees. Now it just says how much higher up the building will one reach than the other. So we're looking for this, right? The difference between those two. So we just need to find this for both of them. So let's start out by finding the red triangle one. So that's just going to be, I'll do it in red maybe. We'll go, so we have hypotenuse and opposite. So which one deals with hypotenuse and opposite? Sine. So we'll go sine of 65 degrees is equal to x over 18. Okay, so that's going to be 18 times 65 sine equals 16.3. Okay, so that's the height of this one so far, 16.3 from there to the bottom. Now let's do the blue one. It's 32, so it's going to be really the exact same thing, but just with 32 instead of 18. So sine 65 is equal to x over 32. I'll put that over 1. So we'll go 32 times 65 sine equals 29. Okay, and then all we were looking for was the difference between those two. So let's go 29. I'm kind of running out of room here. Here. So the answer is going to be over here. 29.0 minus 16.3 is going to be 12.7 meters. Okay, so that's the difference right here, 12.7 meters. All right, So how much farther from the house must the base be when it is fully extended? Compare it to its shortest length. Okay, so I'm going to actually let you guys do this one. It's the same thing, but now we're just looking for this difference down here. So how much farther will it be down there? So go ahead and answer 5B now. Alright, moving on. Number 6, I'm going to let you guys skip number 6 if you want. You can do it though. Don't let me stop you. Okay, number 7. A roller coaster has a track that drops at an angle of depression of 25 degrees from a height of 14.9 meters. When it reaches the ground, it travels horizontally for 8 meters. Then it rises at an angle of elevation of 47 degrees to a height of 26.8 meters. So luckily, this one had a bunch of, it was kind of hard to understand there, but they've drawn us a picture, so we really just need to look at the picture now. It wants to know the total horizontal distance. So all we need is to figure out this part of the triangle and this part of this triangle, and then add it to 8, and that would be our total, right? So, alright, so let's do this triangle over here first. Well, what do we got? Well, remember, if we're looking at this here, I can figure out what this angle is pretty quick, because I know that the whole thing from there to there is 90 degrees. So if I go 90 minus 25, be 65, right? So I know that this is 65 degrees. And that's important because now that I know this, I can say, okay, well, 14.9 is my adjacent side. This is going to be my opposite side. So adjacent opposite, that's tan. So let's go tan of 65 degrees is equal to, we don't know the opposite, over 14.9 meters. So we'll go 14.9 times 65 tan equals 31, I'll say 32. Let's keep it even numbers. We'll say x is equal to 32 meters. Alright, so we got this figured out. 32 meters. We know 8. Now we just need this one here, which is going to be pretty straightforward because we've already got this angle and the opposite side. We're just looking for the adjacent on this one now. So this is just going to be tan of 47 degrees is equal to, we do know the opposite this time, is 26.8 meters over, call this y to keep it different, and that's over 1, so we're going to go 26.8, and then if you want to, times 1, but it doesn't really do anything, same thing, and then divided by 47 tan, and then equals 25. So y is equal to 25, so that's what this is. And now we just need to add that, and that together. So let's go the total here. Let's say t for total is equal to 32 plus 8 plus 25. So plus 8 plus 25 is equal to 65. Alright, what's the total distance traveled by a car on this portion of the roller coaster track? So that seems like the same question, doesn't it? But it's a little bit different because now what we're looking for is the distance traveled, like, you know, along there, there, and there. So I'm actually going to let you guys go ahead and do this, or the rest of this on your own. So go ahead and answer number 7B now. Okay. Now you can see we're dealing with, well, three-dimensional objects. They're still all the same. We've still just got, like, whatever the question might be, we've just got like a triangle inside of that three-dimensional box now. So it's still just triangles. It's more just like drawing the picture that's going to be the tougher part now. Okay. And yeah, if you want to do number 8, great too. But I'm going to let you not do it if you want to too. So yeah, so you can skip to number 9 if you like. Alright, so number 9 says, Sylvie and Matthew were bird watching. They both spot a nest at the top of a tree. Matthew is 89 meters from the tree. The angle between Sylvie's line of sight and Matthew is 73 degrees. The angle of elevation from Sylvie to the top of the tree is 35 degrees. What is the height of the tree? All right. So they drew it all out for us at least, so we kind of have a good starting place here. So what we're after in the end is the height of the tree, right? So the opposite side of this big triangle. And what we need to ask ourselves is, okay, what is actually in common with this triangle that they're making between them and this triangle? Well, the thing that's in common is this line right here, right? That's the hypotenuse of this smaller triangle, and it's the adjacent side of the bigger triangle. So let's figure that out first. So to figure that out, we'll call that side x. We know this angle. We know the opposite side, and this is the hypotenuse. So opposite and hypotenuse, that's sine. So we're going to go sine of 73 degrees is equal to 89 over x. So we'll go 89 times 1, which is kind of a pointless step, but okay, divided by 73 sine, and then equals 93. Okay, so now I know that this is 93 meters. Okay, now that I know that, maybe we'll put x is equal to 93 over here too. Okay, now that I know that, well, I'll actually let you guys figure out the rest of the question. We know that angle, we know that side. What's the height there? So go ahead and answer the rest of number 9 now. Okay, practice your skills. Okay, so for the most part, I'm going to give you guys some hints on these if we need it, but I'm just going to let you go for it. So go ahead and answer number 1A now. You know what? I'm actually going to help you with this one because we haven't done much with the angle part of it. And I just want to do one to make sure that you remember how we put that in the calculator and how we do that one. So let's go through B together. Okay, so what I would do is you can recognize here, we can figure this angle out actually really quick because that's 90 degrees from there to there, right? So if I go 90 degrees minus 57 degrees, I know that this is going to be 33. That should be well, that was a terrible 3. Anyway, you get the idea. So this is actually going to be 33 degrees. Okay, so now that we know that, what I would say is let's go ahead and figure out x, and once you know that, you should be pretty straightforward to figure out y. So I actually changed my mind. I'm going to let you guys finish the rest of this one. Okay, so go ahead and answer number B now. Okay, C. C, I'm going to go with you a bit to figure out that one. So first off, though, what we're going to have to do is figure out x. Well, that's pretty much the only thing we can figure out right off the bat because we know two things. We know that this is 15 degrees right there, and we know the opposite, so we can figure out the adjacent side there. So that's going to be tan. We'll go tan of 15 degrees is equal to, the opposite is 21. We're looking for x. Okay, so we'll go 21 times 1 divided by 15 tan equals 78.4. Feet. Okay, so this is going to be 78.4. Alright, so now we need to figure out what this angle is, and I just want to kind of remind you how that looks. So that's going to be tan again, right, because we have the adjacent, that's the one we have now. We have the opposite, and we're looking for theta. So we're going to go tan theta is equal to, opposite is 70.6, adjacent is 78.4. So now what we do is let's actually just put this in our calculator and make it a decimal. Might be the easiest thing to do. So go 70.6 divided by 78.4. So 0.9, yeah, 0.9. So we can say tan theta is equal to 0.9. Okay, now we got to figure out what theta is. So we're going to go theta is equal to tan, and it's like that inverse 1 thing of 0.9. The big thing is you just need to put in your calculator properly. So we're going to say the angle theta is equal to, and on your calculator, you have to do that second function thing, right? So if you go 0.9 shift, that's what the shift button looks like on mine, and then tan negative 1, that's what we're after. So that, and it actually just gave me the answer right away. So it's going to be 41.98, so really 42. We round up to 42. So we got 42 degrees. So now we know this is 42 degrees. Okay, and then the last thing, you just need to find y. We could have done that before too. There's a few ways to find it now. I'm going to let you guys use one of the ways to figure out y. So go ahead and answer C now. Okay, number 2. Okay, so number 2, I'm going to let you guys work through it. I'll just make sure you can understand what's happening here. The distance between each of these things is 2 feet, so we can use that to figure out probably the total length there is something I'd make sure that I was doing. Or, actually probably it's even better than knowing the total length. I'd say it'd be more valuable to probably know the length from there to there, and then the length from there to there. Because, look what we got. You can make a triangle like that, you can make a triangle like that, and then it just turns into kind of a typical question that we've been doing. So setting this one up is kind of probably the toughest part. But I'm going to let you guys go ahead and answer number 2 now. Okay, so number 3, Guinevere is standing on the top of a building that is 109 meters tall. At an angle of elevation of 41 degrees, she views the top of the neighboring building, which is 147 meters tall. How far apart are the buildings? So the big thing here is being able to draw it properly. Like it's not anything really complicated, or anything more complicated than what we'd be doing, but you just need to draw it out properly. So I'm going to let you guys do the whole thing though. So go ahead and answer 3A now. Okay, 3B. If Guinevere looks down to the base of the neighboring building, what is the angle of depression? Okay, so go ahead and answer 3B now. Alright, 4. So again, this one's going to be one that you're going to want to draw out first. So it says Malcolm is on a canoe trip traveling across a lake. He sees a tall tree on the shoreline in the distance and wants to estimate its height. He estimates that he is about 100 meters from the tree and that the angle of elevation to the top of the tree is about 20 degrees. What is the height of the tree? Alright, so draw it out. That's a really straightforward one, 4A. And then so go ahead and answer 4A now. Okay, and then the last one, 4B, says if Malcolm paddles closer to the tree and then views the top at an angle of elevation of 36 degrees, how much closer to the tree will he have paddled? So, kind of want to make sure you know what he's talking about there. So we've got, the original angle of elevation to the tree. Right? That's the tree on that side. Now he's paddled closer, so it's going to be something like this now, right? So that's kind of the general idea. So if this was my tree, tree was like right like that. It's a tree. Okay. Anyway, so he's closer now. So that's what they're talking about there. There's a different angle of elevation. There's 36 degrees now, when there was only 20 degrees on that one. Okay, so that's kind of what they're getting at. So go ahead and answer 4B now. Okay, that's going to be it. The next one's going to be our Chapter 4 test, and then that's it for Chapter 4. So it's a quick one. So yeah, that's going to be it for that video.